Good evening, everyone, and welcome. And thank you all of you for joining us to this SP event. It's a real pleasure for me to open this event dedicated to the role of robotics and autonomous system for the energy transition. Robotics is rapidly evolving from an emerging technology to a driving and enabling force for the transformation of our industry. Today, we will have the opportunity to see how this technology are contributing to a safer and more efficient and more sustainable operations through the experiences by leading players across the main domain of robotics, that are the ground robotics, underwater, and aerial systems. For application in key areas, application for our industry, such as safety, environmental monitoring, asset integrity, and the new frontiers of energy. The purpose of this event is to connect operators with service providers, with technology developers, and academia in the spirit of SP, sharing knowledge, building networks, and accelerate the progress for the benefit of all. This event is promoted by the SP Robotics and Autonomous System Technical Section and the SP Italian Section. A very special thank to Cristina, chairperson of SP Robotics and Autonomous System Technical Section, who inspired this idea for this event. It is the first European engagement for our section. We are honored to participate. A very special thanks to Andrea and William of the Italian section for their outstanding organizational work, and to all the Italian section team for their support and engagement. A very special thanks to Accenture for hosting us in this exceptional Industry X Innovation Center. Our robotic and autonomous system may represent a niche within SP, but it's a niche that is rapidly growing thanks to a strong participation from students and young professionals, which means that they see in this technology a privileged entry point into the future of the energy. Now, our journey starts with a very special contribution. Jennifer doesn't need my introduction. She is a global reference figure for the petroleum engineering. She has contributed as few others to the SP technical programs. Jennifer is the 2026 president of SP International. It is my pleasure to introduce a welcome message from Jennifer Miskins. After the message, we will have the keynote speech by Paolo Avagliano of Accenture. Please enjoy.
Good evening, everyone. I am Jennifer Miskins, and it is my honor to serve as the 2026 SP International President. It is a pleasure to join you this evening through this recorded message for this unique and exciting gathering taking place in Milan. I truly wish that I could join you in such a beautiful city. I want to thank the SP Robotics and Autonomous Systems Technical Section and the SP Italian Section for bringing together such a forward-looking event. I also want to extend our appreciation to Accenture for hosting us at their Milan Industry X Innovation Center. Today's roundtable captures exactly what SP strives to do at its best: connect global technical excellence with regional insight, and bring professionals together across disciplines, companies, and geographies to accelerate progress. This collaboration between a technical section and a regional section shows how powerful that bridge can be. Robotics and autonomous systems are no longer emerging technologies on the horizon. They are rapidly becoming core enablers of a safer, more efficient, and more sustainable energy system. Whether we're talking about offshore inspection robots, autonomous monitoring in CCS, advanced analytics, or new applications inspired by other industries, these technologies are reshaping how we work and what we can achieve. What makes today's session special is not only the expertise in the room, but the diversity of perspectives that are represented by them. We have operators, service companies, technology innovators, and academic leaders. We have major players like E&I, Saipem, Baker Hughes, and Flyability sharing insights along with advanced R&D voices. And we have moderators from industries outside of our own, helping us to look at our challenges from fresh angles. This mix is exactly how breakthroughs happen. This is a non-commercial, open, and interactive conversation designed to help us collectively map where robotics is today, where it needs to go, and how we can work together to accelerate adoption across oil and gas, CCS, and renewables. You are not just here to exchange ideas. You are here to help shape the future landscape of robotics for the energy transition. On behalf of SPE, thank you for contributing your time, your expertise, and your vision. Events like this strengthen our community and reinforce our mission to connect professionals, advance knowledge, and support a resilient, innovative energy industry for the benefit of all. I wish you a productive and inspiring roundtable. Enjoy the discussion, and thank you for being part of this important journey.
Thank you. Good evening, everybody. My name is Paolo Avagliano at Accenture and Market Unit. I'm leading manufacturing and operations, essentially the team that embeds also what we call autonomous robotic system. And today I would like to offer our point of view on where robotics and the technologies that are making it possible are driving and moving, hopefully providing the framework that can help the discussion. Our point of view starts with a very clear statement. Our North Star is about autonomous operations. We do believe that advanced robotics is pretty much all about augmenting human capabilities in plants and in the fields. And you will see here essentially what we call autonomous field operations, which are, let's say, the environment, the perimeter, where automation and robotics plus data integration will make intelligent behavior possible and will augment our capabilities. If we go next, in our offering at Accenture, you see that we are leveraging a very important ecosystem. First of all, internal to ourselves, where we have key people in our company spread all over different geographies, in innovation centers or here in Italy, lots of professionals that are providing and helping our customer with key technical knowledge coupled with the industry that we know we master and we are serving. Overall, our offering and let's say our capabilities are spanning not only internally at Accenture, but of course we do leverage also external partners that are helping us in complementing and delivering services to our customers. You can see here that from inspection and advanced maintenance, all the way down to what makes actually a robot, Accenture is working to establish a very strong ecosystem, and together with the people and companies that are making this ecosystem, learning together and servicing our customer. If we go next, we will see that essentially our offering. So at Accenture, when we look at autonomous robotic system, we like the idea of helping and working with our customers since the very beginning by helping them to establish a very clear automation strategy as a compass that will drive all the future development. And then we go all the way down with a special focus on what we call field operation simulation. You will see that the role played by virtualization and simulations are key in the today robotics, and even more in the future of robotics operations. And also on our side, we develop specific solution for our customers in what we call to enable autonomous field operations, which pretty much will be the focus of today's discussion, if you want. If we move next, you will see also that all around us there is a pretty much unique situation in terms of market forces and capitals that are feeding the development of the robotics field and the way solutions enabled by new technologies can support our customers. You see the huge spend that is coming in US, but also, of course, in other regions, and the key forces that are driving lots of attention towards the energy transition as well, which clearly is a field that makes robotic particularly appealing, if you want, to make a positive difference in this field. Let's deep dive a little bit more in our point of view of what is happening and where we think things are going with the next slide here. So the main point of attention where we truly believe still robotics will be key in the field operations, it's all about inspection efficiency, safety, data availability, and the asset utilization with the maintenance. Those are key tasks that will be augmented through autonomous system, but essentially from a business point of view, will stay key and will stay on focus with our customer. And of course, robotics are extremely, let's say, appealing when it's about working in environments that traditionally have been an issue when dealing with humans. If we deep dive on these key areas where we believe robotics will make a difference, in the next, please, the focus and from a point of view, the recent developments of robotics in ground, drones, and other underwater is where recent developments will make a positive difference. Let's pause 1 second on this slide and trying to properly understand how advances in other fields we do expect will come into the field operations and will augment current capabilities. First of all, let's start with ground robotics and the role played by LEGT as key. This is, we believe, something that we are experiencing with local autonomy, with edge computer, with the developments into the sensing side and simulation. This is a key area where we do expect major advance. Drones is the other area where traditionally, yes, of course, has been quite strong methodology that we could leverage to deploy drones into the field's operation. But here we have also expectation about an increase in the capabilities and range of autonomies and interaction, if you want, with the data. The combination of drones that are able to carry and trust kind of robots for ground operations, so the combination of both together. The third one, which is actually the most promising one in terms of landscape and opportunities that are now opening, it's the underwater side. Both on the AUVs and the ROVs, those are fields where recent developments will make a tremendous impact in the next year. It's because of the high precision mapping and intervention that these tools can make in a very hostile environment where traditionally humans have been very limited. If we move next, we're starting to deep dive a little bit in some relevant use cases that we have been deploying at scale in several industries around the areas that you will be discussing today, from gas sensing all the way down to patrolling for security reasons, inspection, thermal inspection, power line inspection. You can see those are fields that we do see after some kind of relative success, there will be a huge expansion and growth. And this is where the new technologies also will make a positive difference moving forward. Those are all areas where we can leverage the expertise and we can push into, let's say, the next frontier. Of course, if we have a broader picture, and you can move next, these use cases, when landing into the energy sector, there are opportunities for sure, but we also would like to immediately state some challenges that are essentially key to be addressed since the very beginning to have a proper scale and the proper deployment. So let's start from the breakthrough that we see from the technology side. The future is all about, if you can stay please I would like to provide first of all a bigger picture. So if you can go back please, just 1 second, thanks. So major 4 areas that we are considering here and providing our direction. The first one is on the, as I was saying, on the technology side. So the role played by AUV and ROVs, it's key moving forward, coupled with a very specific definition of what is a robotic arm. This is, I believe, one of the most interesting challenges in adopting the experience and the learning from traditional robot arms that have been deployed in several industries, and having the capability to move literally those robotic arms on top of drones, on top of legged robots, on top of assets that are making the underwater. This is very, very key because of the role of sensing and because of the role of actuation with the new materials and advances in controlling of this robot. Of course, we stay very focused on what is happening at what we call edge. This is actually the area from a technology point of view where advances will make a tremendous difference in the upcoming years, both on the computing side, so having capabilities of planning and control, sensing inferences at local level, so essentially far away from us when this autonomous system will be operating. But most importantly, also, there is a key topic about knowledge base. So today you've been listening a lot about large language models, but how this translates into robotic system and what kind of local specialized knowledge will be needed. This is a challenge from one side, but on the other side is an extreme important opportunity when this system will be operating remotely and have to drive inferences to generate insights locally, autonomously. Challenges that we see in this moment, of course, is extremely important what is happening on the for large-scale adoption. It's all about the economics and the huge cost upfront. I'm sure that today there will be a discussion about, timing and cost to develop ad hoc solution of autonomous robotic system and layers of experimentation and iterations that are needed. But from an Accenture point of view, we do see that 2 factors will be more and more key in the future. The first one is the broader ecosystem in which, since the very beginning, academia is brought into the discussion and the developments to experiment. And the second one is the cost of actuators and sensing side that we do, and compute, that by definition is going to, let's say, gradually decrease with the positive impact on overall ROI. But those economics teams are there and are essential. On the other side, on the technical, from a technical point of view, in this very moment, the key point is knowledge in the industries about bringing scale of what traditionally has been the workforce. This is a key topic that we are seeing it across several industries that have been adopting robotics at scale. Workforce and upskilling of workforce is key to master these new technologies and to deploy at scale. The other key topic is about the quality of data that today are available, and the topic about the reliability of the autonomy of this system. Again, it's a journey, as we used to say, but we do see that this topic, if properly addressed since the very beginning from a strategic point of view, will make a clear and positive difference for those first movers. From a regulatory and organizational point of view, we are all experiencing very singular time in this moment of our, let's say, life for some key topics about regulation and organizational of the business are extremely critical and of course needs to be taken seriously into serious consideration. But that's at least our point, should be very clearly decoupled from the art of possible, from a technical point of view, and from the scale, from an economics point of view. Those are very industry specific in terms of geopolitics, as we know, but it's something that needs to be taken into account into the discussion. If we move next, we will see another key point that we would like to deep dive, and is essentially the role played by the workforce evolution and the role of safety and accountability. Let's be a little bit more into the details of this topic. First of all, we are experiencing a tremendous acceleration from a technology point of view. So the scale at which compute is evolving, for sure, is opening up huge opportunities. But at the same time, a key topic that actually we do believe is probably the most important for adoption is to find the right balance between, let's say, the evolution of the workforce and the evolution of these intelligent assets that will make also part of our workforce. This is a key topic where we are experiencing in some industries a huge acceleration. It's probably because robotics and the topics like software and engineering have been a little bit more familiar or are newer industries that recently experienced huge acceleration. In those industries that are more about legacy driven, for sure, this is a challenge that must be faced again since the very beginning without waiting the move of other players. Technology develops and moves so quickly that assuming that we want to wait and see what will happen in a couple of years can be risky. In some industries, we experienced this very clearly. There were players that were moving, that were acting as leaders in the industry. They decided to wait and have a better understanding of the evolution of technology. Unfortunately, the acceleration of the last 2-3 years pushed these players in a very different situation compared to where they were 3-4 years ago. On the other side, the topic of safety and accountability. Here is, for sure, robots are reducing the exposure of human to risk and danger. But on the other side, accountability, it's a key topic. As always, we try to share our thoughts on this point. It's about the agency. In the moment in which you have an autonomous system performing a task, business and, let's say, needs to understand and drive a line between, let's say, what stays accountable at human level and what's the perimeter of a given task that has been assigned to this autonomous system, and let him play within that field. I would say this is a trade-off that needs to be balanced, both from an operational point of view when it's about risk of the operations of the mission that the asset is performing. On the other side, of course, can be more kind of strategic intent. And so the idea of developing a very clear framework for the industry, it's key and must be managed with the right level of strategic intent. If we move next, we will see overall that when we think about autonomous system, for sure, the underwater, the aerial, and the ground are the fields that will make a huge impact for the industry that we are when dealing with the future of energy operations. Underwater, in particular, is an area where lots of the current, the latest developments in robotics, with specific reference when we think about planning and control, is key to really push the boundaries and enhance what currently is the art of possible. On the aerial side, advances in drones, I think, are very well known to everybody, but still sensing, data collection capabilities, autonomy, those are key subset of this field, of this topic, that are the most promising and the most interesting, if you want, from for the business. On the ground side, the statement is not that everything is done and it's clear, but the autonomous vehicle and the way we are approaching the fields, it's something that still will be extremely important. And in particular here, the role of simulations and virtualization for training in a domain and in a space that is very well known. Consider, for example, field operations is an area of extremely, let's say, rapidly scaling, where we are deploying ground robots for missions that are about inspection, maintenance, and now also we do see the opportunity of having legged that are actually performing tasks that usually are going beyond inspection and maintenance, but actually making things like, I don't know, welding, finishing or polishing, some infrastructure. Those are activities that traditionally have been staying very, let's say, not in a dynamic range, but actually pushed now into the fields. Overall, for sure, what stays important is to think of these autonomous systems as assets that are living into an ecosystem where essentially the capability to orchestrate across different applications and tasks, it's even more important than what we experienced in the past. And therefore, collaboration and knowledge generation, learning across the value chain will be extremely important. That's pretty much what we see. I don't know if there is any question, otherwise I will let Fabio and the people there to keep going in the discussion. Thank you.
Question for Paolo? Okay. I would say that we can move forward. I will ask the speaker kindly to move on the stage while I present myself. Welcome. Thank you one more time. Welcome to come here. This is the Innovation Center of Industry X. Industry X is a business unit of Accenture that I have the privilege to lead, that is focusing on engineering and manufacturing. is a part of Accenture that is quite new. I spend most of my time explaining this unknown Accenture. As Paolo was explaining, we work in engineering, meaning that we do engineer works. We have our own factory. We produce, just a few know that we produce the fire extinguisher for 90% of planes globally. And we design and produce custom robots. Paolo is part of our team, expert on robotics automation. He comes from US, where he was CEO of a startup working on the automation and robotics side. This is why I'm very happy to be here with you, because I know that this will be a very nice and quite interesting from my perspective session. I will ask the speakers to present one by one. I will move on 2 minutes. Before that, after that, I will go with some questions just to start challenging ourselves.
Thank you. My name is Vincenzo Lipillo. I'm full professor in robotics.
Andre, this is me.
So, good evening, everyone. I'm Andrea Vignali. I'm R&D Robotics Project Manager in ENI. I'm an aerospace engineer with about 20 years of expertise in research and development for the oil and gas industry. And I'm in ENI since 2019. My focus is on robotic systems, so aerial, terrestrial, and underwater systems for the inspection and monitoring of our assets. So both for the asset integrity, the decarbonization, and the energy efficiency. Thank you.
Thank you. I suppose the next will be Tiberio.
Yes. Good afternoon, everybody. My name is Tiberio Grasso. I'm 61 years old, and I have a degree in electronic engineer taken at the University of Padua. I work in Eni Progetti, that is the engineering company of Eni, since 1991. And I've always worked in robotics of various types and various scenarios, from subsea to terrestrial to space environment, and adopting various kinds of robots, manipulators, vehicles, legged robots, the drone, and so on. I have been the head of robotics department in Eni Progetti for 20 years. And now I have the role in Eni, in general in Eni, of knowledge owner for robotics engineering. We use, of course, our knowledge and we apply this knowledge to all the projects that Eni requires to us. Last but not least, I have 3 sons. I'm a grandfather since 1 month, and hard to believe, I play guitar in a hard rock band.
Okay. Junio.
Hi, good evening. My name is Junio Valerio. I'm the managing director for Flyability Inc. I've been with the Flyability for approximately 9 years. I'm responsible for the Denver office as well as all our activities in North, Central, and South America. My background is originally in international relations. I then graduated from the Holt Business School. I previously worked in sustainability, but over the last 9 years, I had the opportunity, the privilege, and the chance of working for one of the most exciting robotics scale-up at this point. Flyability is 11 years old. It's a spin-off of EPFL. Has 140 employees, the majority of which are based in Lausanne, Switzerland. Thank you very much for having me, Luigi. I really appreciate the opportunity. Thank you, Accenture, for hosting us, and I look forward to discussing this very interesting topic with the rest of the panel. Thank you.
Thank you very much.
Good afternoon, everyone. My name is Cristian Nevoso. I'm an electronic engineer, and currently I'm working for Saipem since 2007. Today is 18 years. I mean, my anniversary in working as anniversary. Currently, I'm a solution manager for subsea drone, so I'm responsible for leading the subsea drone development within Sonsub Robotics, finding the right compromise between what the technology can give to the clients and what the clients are asking for. I'm an electronic engineer. I worked mainly for robotics during the last 10 years when we start developing the iDrone platform, which is currently our main focus in Sonsub Robotics for introducing new concept of resident robots for underwater inspection. Thank you very much for the invite.
Thank you. And so,
yeah. Good afternoon to everybody. My name is Lorenzo Salusti. I'm a mechanical engineer. I'm working in Opinione Bakery from 23 years. And I moved different roles, starting from the field service, making troubleshooting at site and testing. Then I moved to remote monitoring services, then quality leadership, and then now I'm in the product leadership team. I'm leading now the strategy and the development of new products for field services. So we are continuously improving our field services through innovative technologies, creating a better environment for our field engineers, improving the quality, productivity, and safety in the field. In this particular project, I'm leading the program to adopt autonomous robots to improve the inspection job in the field. What else? I have two sons. My hobby is have a ride with my bike. I like photography. Nothing else. I think it's all.
thank you. So, see. My name is Vincenzo Ricchiello. I'm a full professor in robotics and automatic control at the University of Naples, Federico II. I'm also leading one of the three main laboratories in robotics that we have at the University of Naples. In particular, I'm leading the group of address the industrial robotics part, legged robotics, field robotics in general, all the part of service robotics, except the surgical part that is in a specific new facility that we created in our university hospital, and also the ideal robotics part. So I'm also the founder and CEO of a startup company from our lab. The name is Robotics. That is mainly active in design and development of new robotic solution for inspection and maintenance, with mainly in the fields of oil and gas, but also now we are moving also in the power line maintenance and some things in logistics.
Thank you very much. By the way, before starting, I met the Professor Lippiello some months ago in Naples, because I discovered just some months ago that one of the guru in robotics all over the world is in Naples. There is Professor Siciliano, that is the author of some books used also today at the MIT and Stanford. So something new that I learned some months ago, and I know very well the Neobotics products that I was talking before with some of you. Okay, the organization, if you don't mind, there will be, I will go now with some questions, hopefully in 2 rounds. The first one is about, let me say, which are the product and technology that those companies are using, of course, with a focus on energy transition. The second round will be on challenges and the future. So the challenges about innovation, what we will see in the following years, and so on and so on. If you don't mind, the question will be at the end of the second round, so please take note, and we will have time at the end to make the question. I will start with the colleagues from NAI, and I know that the NAI is going through a deep transformation that is focused on sustainability, safety. So my question, and onshore and offshore. My question is what you are doing, which are your products on this regard? Thanks.
Okay, so thank you, Fabio. Yes, in the past years, Eni has embarked on a deep and long-term transformation towards sustainability and energy transition, mainly driven by the need to address global warming, but at the same time to guarantee access to energy for all. So this means we need to adopt solutions with a low CO2 impact, while gradually shifting from traditional energy sources like oil to new, cleaner ones. And this is exactly where robotics can play a crucial role. In particular, robotics can contribute to Eni's transformation, acting on three main, let's say, levels. The first point is that robots can improve or even enable production processes by providing continuous monitoring, predictive diagnostics, and by reducing human errors, thanks to the acquisition of more reliable, accurate, and frequent data. The second point is that robots can increase the safety of the operators by enabling remote operations, so that people can limit their time in hazardous environments, such as areas with the presence of toxic or flammables or work at height and so on. And the third point is that the use of robotic systems can be crucial for the detection and mitigation of greenhouse gases emissions. And this is one of the pillars of our strategy towards decarbonization. So this framework to pursue our objectives, we created an internal team with people from the R&D department, from the business units, from the Eni Progetti, and we started several cooperations with universities, research centers, and technology providers to create a sort of ecosystem which covers the entire life of a robotic prototype, from the definition of the requirements to the design, manufacturing, and field testing. And in this way, we can leverage on the synergies between academic and industrial expertise to speed up the technology development and to be ready for future commercialization and operativity of the systems. So now let me make a couple of examples of our robotic solutions. The first one concerns the detection of fugitive emissions. Fugitive emissions are small methane releases from plant equipment and items such as flanges, valves, pumps, and so on, which are very small, but overall can account to 4 or 5% of the global greenhouse gases emissions. And the current practice is that operators with handheld instruments perform these monitoring activities periodically, every 1 or 2 years. So in Eni, we try to address this problem because this strategy clearly cannot reduce in a significant way these fugitive emissions by developing 2 technologies we can work in cooperation. The first one is an innovative drone which can operate autonomously in very complex areas, such as our plants, so where there are GPS-denied areas. With you can see here in this video in the bottom, with take off from a special docking station, flight along pre-programmed routes, scan of each element of interest to detect anomalies, and return to the docking station to recharge the batteries and download the acquired data. For the points of the plant not reachable by the drone, we developed a minimally invasive sensor called the gas sensor node, which is very small and battery powered, so autonomous from an energy point of view, and can be installed directly on the potential leak points to have a continuous monitoring of the facility. And it is important to underline that these two technologies are certified to operate in the presence of a potentially explosive atmosphere, so they are ATEX certified. The second example concerns the field of carbon capture and storage, so CCS. Because in this frame, we have to perform environmental monitoring activities required by national and international regulations along all the steps of the CCS value chain, so capture, transport, injection, and storage, to be sure that the captured CO2 is not released into the surrounding environment. So for onshore applications, our strategy is similar to what I described for fugitive emissions. So simply changing the sensing element, switching from methane to CO2. But for offshore applications, again, we rely on two technologies. The first one is the Clean Sea. You can see here in the upper part of the video, which is a hybrid AUV, ROV subsea robots, which can perform simultaneous asset integrity and environmental monitoring surveys. It can acquire data on a wide area through spot campaigns for the geophysics of the seafloor, for the characterization of the chemical and physical parameters of the water column, for water sampling, and of course for CO2 detection. Recently, we developed a new patented solution based on the real-time analysis of data acquired by forward-looking sonar, which is able to detect very small subsea gas plumes and can autonomously adjust the trajectory of the Clean Sea to go directly to the point of interest to deeply investigate the anomalies. And the second technology is a seafloor venting station called the LiDAR, which is equipped with the sensors able to characterize the chemical and physical parameters of the water column, and can work in synergy with the Clean Sea. Clean Sea is meant to be used for spot campaigns on a wide area, while the LiDAR is used to continuously monitor a specific point of interest, for instance, a wellhead, and so on. It is battery powered. It can be in operations for 10 months, and it can transmit the acquired data with an acoustic modem directly to the Clean Sea. So these are just two examples. I'm going maybe too long, so I leave the floor to my colleagues, but this is to show you how robotics is already contributing to our strategies.
Yeah, I think that you touch a very important point that was also mentioned by Paolo before. There is the wide ecosystem and the important to work with academia, a startup, and also scale up. Yeah. I don't know, Unio, I saw that during the past session, everyone was asking you several questions and so on. So I don't know if you can comment or they know just everything about the products, but what you are doing and how your products is used nowadays by clients like NEI and others?
Well, I think one of the challenges that we had in the past with NEI was the ethics issue, and I think that they managed to solve that internally, because indeed has always been sort of a bit of a difficult point to address. As far as our technology is concerned, and you can see some of the images here at the background, I can confidently say that there has hardly been any confined space in major industrial assets, whether it's a refinery, infrastructures, bridges, sewers, mines, or indeed power plants, that hasn't so far been inspected with our drone technology. From a technological perspective, I think the real turnkey solution, what really sort of projected us in the 21st century, was the adoption of the LiDAR module. That was really one of the most challenging decisions from an engineering point of view, but it's also something that opened the doors to so many further innovation and is still delivering results nowadays. So lighting, imaging, detection, and ranging, it's the basic of the LiDAR technology, is basically what has allowed us to unlock all the other payloads that we currently have on the drone. It's really the passport to all the other possible payloads that we have mounted, and it's indeed what gave us the opportunity to navigate in confined space areas that are GPS denied. That's sort of the biggest difference between our drone and pretty much 99% of the other drones out there in the market. It's the ability to navigate safely areas where there is no GPS, and LiDAR, it's indeed an integral part of this navigation system. Furthermore, and we see some examples right here on the top right quadrant, is the ability to generate high quality point cloud. This has proven to be instrumental not just for the localization of the defects, but also for the ability to then export this data into ERP systems and make the deliverables more client friendly. Again, without adoption of the LiDAR, this would have been pretty much impossible. The LiDAR has also enabled the utilization of better simultaneous location and mapping, or SLAM algorithms. So once again, it's not innovation for the sake of innovation. It's really what can deliver the most robust product, what can deliver the best customer experience. I think something that Flyability has done very well throughout the last 11 years is really the ability to incorporate customer feedback. So feedback from the first version of the product was very difficult to maneuver. The protective cage, that it's an integral part of the design, was really limiting the view. So in the second version, we removed that, and we increased the maneuverability of the drone with the use of optical cameras. Still not as easy to use, especially for people with not a lot of drone experience. And the key element that we wanted to provide was the localization of the data. We are in the city of Pirelli, so I thought of that amazing advertising from the 1990s that said, power is nothing without control, data is nothing without context. So we wanted to be able to provide the ability to geolocalize as precisely as possible data, even inside areas that have no GPS. So that's also where the LiDAR comes in. Finally, once again, you can have the best possible high resolution videos, you can have the best cameras, you can have the best, most extensive payloads, but if you're not able to translate this into user-friendly reports that can be processed in the client's ERP system, or that cannot be distributed effectively and efficiently inside an organization, then it's just data for the sake of data. So once again, I think that the Helios 3 was as much as a work of hardware improvement, as much as it was a work of software improvement. We really spent, if you take a look at our job advertising over the past 2-3 years, we went from looking for 70% mechanical engineers to 70% software engineers. It's a product that was designed to be lasting from a chassis and module point of view for several years, but with the capabilities of the onboard processing, we're still relying on the same hardware, but the software capabilities have increased exponentially. And this is, again, thanks to the LiDAR. We can talk about autonomy, we can talk about repeatability, we can talk about automation. So it's very interesting to see how effectively using the same hardware design of right now 4 or 5 years ago, we are still able to improve on the intelligence of the system. Without actually modifying nothing about the original components. We're just really working on the DNA, if you want, of the machine.
No, you're right. I think that I was some years ago speaking in a session with some industrials, and the reason was how robotics now is changing because, for example, of the NVIDIA and the computing power that is available to make simulation and all the other stuff. So surely what you said, the advancement of software and so the autonomy, the artificial intelligence on board, surely can even improve with the same hardware, the level of application.
Yeah, as a matter of fact, we were some of the very first manufacturers to use NVIDIA chips on board of the drone. But again, when we started doing it in 2019, NVIDIA was probably valued at a few dollars. Sure. It certainly was not the behemoth that it is right now from our corporate.
Maybe the GPU was available in the supermarket.
Exactly, yes.
So finding one is...
Yeah, exactly. It's like finding an honest man in parliament. So, no, indeed, we were... I think there is always a certain element of chance and luck in product design. I think we were lucky enough to... Well, even back then, NVIDIA was probably designing the best GPUs. We just didn't expect this to sort of become really a major Trojan horse in the best possible way into the next generation of drones.
Thank you very much. I was some weeks ago at the Polytechnic of Milan, where they are working on a new observatory on the intelligent robotics. I had the chance to spend some time with colleagues from Saipem on the Hydron. So let us know what Hydron is contributing to the energy transition and all the other stuff.
Yes, see, since 2015, more or less, Saipem started a new approach on underwater inspection and intervention. And this was, the key element for introducing this new family of vehicles was the need, to answer the need coming from the market to change the way of operating, so reducing the number of vessels that are working all around, so reducing emission, reducing cost, and reducing even the risk of such operation. So for this reason, we started studying a new set of robots. In Sonsub, we have more than 25 years of experience in ROV. So we know very well how to develop a subsea robot. But then we needed to change our mind even on introducing a new concept. So without having the human in the loop while performing such kind of operation, but it's starting introducing more artificial intelligence and more autonomy on the vehicle. And this was the key point for basing of the Hydron platform family, which is a set of vehicle. Currently, we have 3 models. The Hydron R was the first one. It's an hybrid ROV AUV vehicle with inspection and light intervention capability. Then we developed the Flatfish, which is instead a more an advanced autonomous underwater vehicle, specifically for inspection. Even if we are introducing even some touching capability, but we are still focusing on inspection task. And the last one that we just complete development is the Hydron W, which is instead more a world-class ROV with artificial intelligence and more, I would say, intelligence capability. All these vehicle as the main characteristics, that was the one, the key point that we try to introduce with the new set of vehicle, of being resident underwater for a few months without the need of having a support vessel. So actually, the vehicle can remain underwater, installed in a docking station for recharging batteries or for exchanging information to the surface. Without the need of having personnel working offshore with a tether connected to the vehicle to piloting. So, significantly reducing cost of operation and CO2 emission. This vehicle can stay underwater, controlled from a remote control station, while performing an autonomous mission or even a remote controlled operation through a remote piloting. So enhancing the frequency of inspection that you can perform, even because the cost of your inspection reduced significantly when you remove the vessel from the picture. And so you can provide a lot of more data to your inspection campaign. The first service contract has been started since 2019 with the Hydron-R and the Hydron-W. I think that some of the picture that you are looking at back at the moment is the Hydron-R working offshore. Yes.
Some seconds.
Yeah, exactly. I mean, this is one of the vehicles that is currently working in a resident configuration in Norway for Equinor. Is working in 300-meter water depth, performing inspection and drilling support to those operations. It was the first vehicle capable to work in a resident configuration, and it will remain underwater for 8 months continuously in a continuous dive without any downtime. And so this was one of the main challenges that we had during the qualification process of the platform. That was reliability and the fact of remaining underwater for such long time without recovery. It was a main challenge. We achieved it. It was a very good result for us. Now we are, even the other vehicle are, targeting the same kind of deployment, while introducing new capabilities for autonomy inspection and for specific advanced inspection is another parallel challenge that we used to work with. During the last, we started obviously as Saipem focusing on the inspection of oil and gas asset, but then we also moved to other type of application. First was the renewable field, so offshore wind farm was one of the target for this kind of drone. So we performed some studies for deploying the drones in those cluster of offshore wind farm for inspecting, for example, the electrical cables, riser coming from the top floor to the seabed, or for the foundation of the wind turbine. And another application that we are working exactly in this period, I would say in these days, is the carbon capture and storage. In fact, with the flatfish, we are developing a specific payload skid with a CO2 sensor capable to recognize leakage of CO2 while the vehicle is inspecting a pipeline and there is a CO2 injection in that phase. So obviously it's something that is, it's a new concept and a new introduction that we need to do on this kind of application, but obviously need to be led together with what is the common inspection capability for oil and gas industry.
No, thank you. I think that's one of the key points that we are discussing is the application finally of the robotics. No, I think that Baker Hughes as a platform is using robotic solution, but is of course more focused on data analytics and so on than on the hardware. That is important, but I would not say it's a commodity, but it's something to, I would say, to work together with the manufacturer.
Yeah, exactly. Let me start from the beginning. We started around 3 years ago by exploring this technology, and we created from the beginning a team pretty dedicated to robotics. And then we purchased a couple of robots to study the technology, to make tests and in our internal environment. And we started to invest from the beginning because we had in mind the two specific strategy points. First of all, we want to be independent from any suppliers and external contractors. So we wanted to create internally capability to create value with robots for our customers. Secondly, we want to be agnostic for technology because this kind of hardware is continuously evolving. So we don't want to be connected exclusively with the supplier, but we prefer to stay open to any new robots and solutions we can arrive on the market. So another important point is that, as said, we are not selling robots. We are not manufacturing robots, but we are selling services enabled by robotic solutions. We already have a remote monitoring center, one in Florence, one in Kuala Lumpur, and one in Houston, monitoring our fleet around the world. We have a 2,000 and more unit under rotating equipment under monitoring. We are using the fixed sensors of the asset. So the monitoring is based on the standard sensors we have on the gas turbine compressor and so on. The robot can add the capabilities to prevent anomalies and problems because the robot can complement this kind of stuff of data with images, thermographies, noise. So for us, the robot is, like I said, something like commodity to capture more data, to be stored and analyzed. So what is our added value? We take the robot as it is from OEM and we create the intelligence because the robot is trained in this way with artificial intelligence or computer vision to recognize a list of anomalies typical of failure modes of rotating equipment. So the robot is able to recognize what is going wrong, what is not normal in the standard operation of rotating equipment. And all these data are automatically analyzed by computer vision. Then all the data are not stored locally, and this is the second part of the service, are sent to this diagnostic center remotely, where there are people all the day present because they are shifting around the world the monitoring in order to cover all the day, analyzing data and alarms. So the robot is continuously sending data to the center, and there are diagnostic engineers continuously working on this data. This is the service. But it is not only a matter of quantity of data, because in this case, we are speaking only quantity, but also quality. Because with the robots, we are not only capturing images and thermography, but we are continuously exploring the market of sensors, because we want to integrate in our roadmap more sensors to the standard type of sensors in order to be able to capture methane fugitive, leak of air, leak of oil, vibration measurement. Everything can be related to rotating equipment failure. And it is another part of customization because the robot is designed to be agnostic in front of the inspection to be made, but we are specializing not only the analytics in the software, but also in the hardware, the sensors to make the robot more effective for rotating equipment monitoring. The integration of sensors is a bit critical because, as you know, we have to work with certified technology. We need to keep the ATE certification when it is available on the robot. So in case we integrate something, we lose the certification. So we have to cooperate with OEM in order to drive in some way the development of the robotic solution, in order they can integrate in the future what we need in terms of sensors, keeping the certification ATE certification valid. This is the challenge because we are in two different shapes. You know, we own the rotating equipment use cases, but we cannot manage the technology. On the reverse, the OEM can manage the technology, but it doesn't know the use cases for oil and gas. So we have to cooperate in order to create value and to give the customer the best value collaborating. This is the challenge.
Thank you very much. I would touch another point. For the moment, you need to wear the hat of the founder of Robotics, because we have been talking with the giants, but I think that the space is so interesting, innovative, that there is space for startup for new entity. I personally fall in love with Koala. What is Koala?
Yeah, Koala is one of the solutions that we developed in the last, let me say, 3 years. It's a project that has been founded mainly by Equinor in Norway in collaboration with the Hacker Solution. Yeah, it's a new concept about a combined solution with 2 robots. One is a drone, it's a shuttle drone with the capacity to fly in a GPS-denied environment and transporting another custom mobile robot, a special crawler. This drone is able to fly in complex environments, recognize the pipe. The target are pipe racks. And once that a target pipe has been recognized, the drone is able to land autonomously on a pipe, selected pipe, clamp the pipe in a firmly way, and then release the mobile robot in different locations. The aim is to try to remotize the capacity of a human to perform measurement. So in a way that we can reduce risk for human operators working at hay. But just remotizing the measurement part. So the crawler is, in this case, is a special crawler designed with a 3-wheel actuation system, not based on magnets. So it can be just a clamp around a pipe like a koala with just a friction forces. This allows the system working both on horizontal, vertical pipe, elbows in any direction. Can rotate around the pipe in a way to reach any kind of configuration, measurement points. This first configuration, we mounted a rolling UT probe for thickness measurements in a continuous way. So the system is able to measure, to acquire A, B, C, and D scan in an automatic way in a selected point by the remote operator. Once that the measurement has been complete, the crawler can operate up to 3 hours remotely. Once that all measurement has been performed, the operator can just move the robot in a safer area. The drone can back, can recognize automatically the crawler, land with a high precision on the crawler, and just clamp the crawler and come back at home with the crawler without the intervention of you. This is one example of a solution that we developed, but we have many examples of drones that try to create a flying physical AI. So the idea is to try to remotize the human hand to replicate the human capability to perform operations in air in a way to reduce risk for operators and reduce costs for companies. Put possible together. We also developed other drones, for example, for the assessment of concrete for bridges or similar structures. Again, with the systems that are able to perform measurements like human being in a practical way. Now we are also moving, there are no images because we have an agreement with a company in Germany for the development of drones for power lines maintenance, for example, installations of belt diverters in Germany are required in many cases, installation of stabilizers, separators, patches for roads, stuff like that. Again, avoiding the use of helicopters, cranes, scaffoldings, all very costly stuff, but most of all, all very risky jobs. So, we are trying to avoid such risky activities.
So nice. I really love, as I said, that. So I don't know, Luigi, if we have time, I will go for the second round, and we need to go to Tiberio. Tiberio, one question, because thanks to my colleague Antonio, I think that I have been for most of my professional career, so more than 20 years without talking one single minute about the nuclear. Now, since that nuclear is everywhere or is going to come, given the complexity, but what is I would say, the link between nuclear and the robotics?
Yes, thank you very much. Nuclear fusion, as you probably know, is one of the most advanced scenarios for energy transition. Around the world, there are many initiatives aiming at energy production or experimental projects to test specific technologies to be used in future energy plant based on fusion. Eni in this field is strongly committed. Eni believes a lot and invest a lot of time and money in this field. We can say that two of the most important projects that Eni follows are CFS, that stands for Commonwealth Fusion System, aiming at energy production, and DTT, that stands for Divertor Test Tokamak. That is a project to be implemented in Italy, in Frascati, and managed by Enea, aiming at the test of special components called divertors, from which Divertor Test Tokamak, that are the key point for the conversion of, let me say, nuclear energy into heat and then electricity. In this framework, robotics is not an option. Robotics, as you can imagine, is used to carry out maintenance tasks. Maintenance means basically replacement of some objects inside the tokamak. Remote handling can operate also outside the tokamak, but is less critical compared with the robots that have to operate inside the tokamak. The criticality is because the internal of the tokamak is radioactive. Compared with fission systems, radiation is much lower. But nevertheless, there are some radiation levels that avoid the presence of humans for maintenance tasks. So robots needs to be used. It is fundamental.
It's not an option.
It's not an option. By the way, if you cannot have a credible remote handling system, you cannot get authorizations to switch on the system. So this is not an option. It's absolutely fundamental. In this framework, designing of such systems presents a lot of challenges. First of all, the main challenge is reliability. It is not a joke to say that the first requirement of such systems is that the system shall be removed from the tokamak in case of failures. The system cannot remain inside the tokamak. So reliability is absolutely at the highest level. Of course, we can use additional equipment, additional robots, in case our robot for the maintenance is completely dead. So we can go inside with other robots, unlock some joints, operate some parts of the robot itself. But the main point is that the robot shall be removed in case of failures. This is the first challenge.
Yeah, we exchanged some messages, and I like when you wrote basically to me that the problem is to make the robot back again.
Yes. This
So
is really
that's incredible, no?
This is the first requirement, really.
Thank you.
Really.
Junio Valerio, with Lorenzo, we talked about data analytics, but he pointed out the quality of data, no? Because the application needs to rely heavily on how the data is qualified, how precise, and so on.
Yeah.
How do you see the future?
So I think one of the most probably few tangible elements, one of the few tangible areas in which there is definitely already an application for artificial intelligence is everything related to image detection. So one of the big challenges that we have once deploying any kind of robotic system, it's really sort of this sudden data burden, this data surplus that companies have to handle. If I think, for instance, of the field of oil and gas, in the space of a few years, we went from engineers, inspectors going around with a paper and pen to terabytes and terabytes of information. So aside from all the hot air that is surrounding artificial intelligence, I genuinely believe that this is one of those areas and elements where image recognition fostered by AI can really provide tangible benefits and results. In terms of the accuracy of the information, we are deeply dependent on the platforms that we use. So obviously, a bit as in the case of the previous speaker, the ability to deploy certified tools, it's mandatory. In our case, we rely primarily on payloads such as Geiger counter or NDT probes that have already been manufactured by companies with years and years of experience. We're certainly not going to reinvent the wheel and come up with a new UT probe when there is Cygnus Instruments that has been doing it for 50 years. It's very interesting to see how before he went completely crazy, one of the interesting things that Elon Musk said was that when we talk about automation in cars or any kind of new innovation, the burden of proof for the innovative player is always higher than for the status quo. So he said, if we try to automate taxi rides, and the rate of accidents with a human is once every 10 million rides, we have to do better than one accident in 10 million. Otherwise, we might as well stick to what's current. So what's interesting in terms of innovation is that as much as the benefits can be clear, the burden of proof for anything robotics related is always higher than the current state of the art. What is very interesting, very motivating is to see that even in an industry as conservative as maritime, we are starting to get traction. We are starting to get people like American Bureau of Shipping interested in the way that we are gathering data and in the way that we are generating the data, measuring, and they're validating it externally. So even a sector as conservative as maritime that went in a space of less than 10 years from you have to be physically there to take the UT measurement and nothing but the eye and the hand of the inspector can vouch for that UT measurement to something as far as it is today in the latest version of the ABS guidelines that remote systems and measurements through UT probes with remote operated vehicle have the same value. That tells us that there is an interest, that there is a technology backing, and there is an appeal for this kind of technology. Most importantly, it tells us that there is an accuracy that reflects, at the very least, the state of the art and can deliver the same results with far less time, far less risk, and far less money.
Yeah, no, thanks. It seems to me that, creating a fully autonomous vehicle undersea, over the sea, and so on, might be something that is reachable. And in fact, we are doing. But the challenge is make working all together a fleet of a fully autonomous. So Christian, what's your view?
Yeah, I mean, we faced a lot of challenges since we started with this new development, specifically for, I mean, I would say technical and strategically challenges, because honestly, as soon as we introduce also a new kind of business model for a new way of operating apart from the technical aspects, we really need to face, even with the prejudice coming from some of the operator or some of the person that are within this field, you know. And at the beginning, I mean, one of the main challenges that we had when we start talking about residency, it was reliability, of course, because you want to remain underwater without any downtime. But for doing that, we also ask for help and collaboration to third parties for helping us on qualifying properly the things. And one of the main challenges at that time, 10 years ago, it was no guideline, no specific guideline for this kind of solution. And so, I mean, this was something that we need to invent together with them, with the best practice that it was at that time. Now things are evolving even in this sense. So I think that it's easier today to start with the project that we started 10 years ago at that time. Then the introduction of more autonomy and more artificial intelligence, more algorithms that are much more complex, even in terms of EV calculations. So, I mean, we mentioned NVIDIA, how they improved during the last few years, and how we need to follow this kind of new technologies year by year, because it's something that is not, I mean, what you are using today is not what you will use probably in a couple of years' time, because it's evolving very, very quickly. Then even, I mean, we already mentioned the fact that a lot of data are now present in this kind of robots and managed by this kind of robots. And there is even the challenge coming from the cybersecurity. It is something that is increasing a lot, even in terms of requests coming from our clients, in terms of be compliant with specific rules, specific regulation. And this is not, very easy sometimes with a system that is already being developed in a way and then changing everything to comply with specific rules. Then there were obviously the strategical limitation and challenges that instead is overcome the traditional mind of using something that is now robust, mature. I mean, thinking about ROV, for example, it's something that has been used significantly during the last 20 years with very good results in terms of response, in terms of technical and operational aspects. And now introducing something new, which can be not very convenient at the beginning because there is a bigger capex that you need to digest somehow with the new operation, with some efficiency that sometimes can be lower at the beginning, at least, or challenging for some specific scenario. And so you need to invent, that kind of application. I mean, this is a greater part of the time that I spend with the clients on finding, the best compromise on how to try to introduce this kind of new technologies in parts and in fields, in scenario where it's really very useful and,
Sure.
can bring advantage.
No, you're right. But I think that there is another point that's when we talk about the introduction of robotics, sometimes is, I would say, mistaught in sense that everyone talks about robotics and no one will exist anymore. While at the end is a matter of change of skills and workforce upskill and so on. What's the view of Baker Hughes about I would say, how we make robots working with the new generation of workers?
Yeah, this is a very good question. And many times the robots are doing what the humans are doing today. This is the challenge because we are not adding new jobs, but we are in some way overlapped with humans. So the fundamental concept is that the robots are helping people doing the job and not replacing people. So many times in the field, humans are asked to do very simple jobs, very low added value inspections in dangerous area with toxic gas, bad atmosphere, out surfaces, bad weather conditions. So, and the value of the humans are very limited in this kind of stuff. So we use it to replace, in general, in many tasks, people, help people with the technology, where the people cannot do the added value. And this is the case because for the inspection in a dangerous environment, the robot can operate very easily in a safe way instead of humans, because we cannot use the humans for just to read the manometer or to verify if there is a leak of oil, wearing a lot of PPE for just 1 minute inspection. So this is the point. And it's important also to say that we are not removing people from the field. We are changing the kind of job. We are moving these same people doing inspection to manage a fleet of robots. And this is the challenge, because today, let me say, the robots are not so easy to operate. We need to train people to do this new job. The same people doing inspection cannot do robot management for a lack of expertise. We have to transfer knowledge from robotic expert to field personnel to make them able to move from the field to a controlled environment where they manage the robots. Because the robots today are not so fully autonomous as we say. They need assistance, they need repair, they need humans. The humans are not of the game, they are changing role. So the same people doing a job, they have to change. And there is no immediate value, because as always happens when there is a transformation, the value is not immediate. We have to invest in training, and the benefit will arrive later on. Like in the first industrial revolution, when the artisans were moved from making the product to manage the machinery to create the product. So immediately it was a cost. It was a lot of time spent in creating this changement. But after years, we increased the production, we increased the quality of the manufactured items, and we increased the safety of people moved out from the production area. So this is the challenge, to instill the concept that we have to invest and we have to spend time to transform a job in another one, but with a greater value for both, for the industry, for the people, for the environment. So the benefits are not immediate. We have to believe in this changement.
So at the end, we have two questions for the professor.
There is also, if I may, sir, we always talk about the risk of robots replacing humans. There is also the reality of the job market. So working a lot with the market in the US, I deal with a lot of inspection companies, and for instance, power line or telecom inspections with drones has become really common. The CEO of one of the largest inspection companies in the United States was telling me that in the next 50 years, more than 70% of the personnel dedicated to the inspections of powers and telecom lines will retire, and it will not be replaced. So in a lot of situations, it's not a matter of robots kicking humans out of their jobs. Very often, especially when we talk about critical infrastructures, it's going to become a necessity. It's not going to be a matter of choice. I don't know what's the situation in the subsea welder job market, but I also imagine that there's going to be a scarcity of skills and people in that particular sector. So it's not just about replacement. It's really providing an alternative to something that most likely is no longer going to be there.
No, I think that this is a very good point. Also in Italy, I've been discussing also in the last 2 weeks with several clients about what we call the knowledge capture. The people that are going to retire, and there is no one in the younger generation that has the right knowledge and so on. As I said before, at the end, those are two questions for the professor, no more the founder of the robotics. One is how we will have in the future the right people with the right competence. And second, since we understand that we need to work across academia, startup, scale up giants like NEI, Saipem, BKUs? What's the secret sauce?
First is easier. So, well, mainly I think that universities should be more open to the necessity of markets, of labor markets, because I see, I'm a professor now, 20 years that I'm saying university, I see it's really not easy to change the way universities teach and what especially universities teaching. But let me say that in the last years, something is changing because the AI, especially all connected to AI, is changing a lot the world, and the university as well is changing. So my feeling is that if a good compromise could be the creation of a value in terms of courses that could have some partnership with the companies, big international or national players that can have, let me say, some slots of also teaching hours, but in a way that to open the university to some things that help students to follow the right way, the right direction in the life in terms of what they want to do after the bachelor, after the master, and so on. So this could be a good way to work. Also, there are opportunities that PhD companies can, if you money, found a PhD in the university, and is, from my point of view, a good opportunity to grab knowledge from university at low cost at the end, because it's very low cost. You can also, it's without the taxes, it's a very good opportunity. And so there are many ways. So we are trying to open, but slowly, but we are trying to open to new solutions. In terms of research, university is very fast, but in terms of teaching, a little less. So about the second question,
the role of spin-off.
Well, I think the role of spin-off nowadays is crucial because I spent many years of my academic job working in funded projects, European project, national project, and we gathered a lot of knowledge about many fields. We developed also some interesting solutions. We publicized this on media, on publications, and after some days, typically some companies call me, oh, I see this video, very nice, where I can buy it? And so at the end, I can just say, okay, well, no, we are in university, we are just performing.
Full Accenture.
Yes, like so at the end, yes, we can do something, but the typical university can work well from TRL 2, if you know TRL, no? To tier 4, maximum 5. So we stopped. So universities, they cannot do more than. So I think that a direct technology transfer from university to companies is possible, but only if your company have a very strong R&D department, because we should speak the same languages.
Yes.
So if you have any project, any big players have this kind of capacity to receive a direct technology from the university. But Italy, we have a lot of PMI where there are no R&D departments, so there is not this possibility. So I think that a spin-off company could fill the gap between universities and small and medium companies by developing products for a very nice or strict markets that otherwise cannot found a solution, because we, as a university, we cannot generate product, we cannot provide a maintenance service or stuff like that. It's just train. And so spin-off company, I think, would be a right solution for that.
Good. Okay. I thank you very much for what you explained. Was very, at least from my perspective, was a nice, comprehensive storyline about what's happening. I don't know how much time we have for questions and answers. 10 minutes. Perfect. Any questions? Please, if you can introduce yourself and.
Yes, I'm Andrea Tondelli from ENI, work in the reservoir department. Actually, I have a question regarding the subsea autonomous.
Saipem.
Saipem, yes. It was regarding the fact that in the image there was a lot of like it's called QR code to actually identify probably the path. But when you're planning for autonomous say surveillance or inspections, do you need to say place in advance all this QR code, or you can say use the autonomous also in the, let's say, old facilities?
Well, the QR code that you have seen in the picture are mainly for docking and undocking, helping, I would say, installation, because it's something that we used to install by ourselves only on the docking station, while instead the vehicle is capable to inspect pipeline, structure, riser by recognizing the shape of the asset that need to be inspected. So through feature recognition, it can autonomously find the right pipe to be inspected. We even with the help of a digital field map that is embedded internally in the control system of the vehicle. So actually the vehicle can autonomously navigate to the target area where the pipeline is, and then through feature recognition capability can autonomously recognize a pipeline shape and start following without any use of additional QR code or additional installation that need to be performed. We used to do with QR code only for those installations that we used to put underwater. Docking station is the typical example, because it's something that obviously can help somehow to recognize easily the shape of a docking station. But for all the rest, the vehicle is completely capable to perform an inspection without any additional installation in the brownfield. This is exactly because we want to use this technology not only on the new fields, which are less and less, unfortunately, but especially for brownfield, which are 99% of the field are not equipped with the QR code. So we need to, it was one of the main challenge also while we were developing the technology, because we needed to introduce this artificial intelligence capability of recognizing things, a Christmas tree, a manifold, a riser, and the vehicle need to then perform an autonomous navigation, so creating its own path, while seeing and recognizing what it needs to inspect.
But that's also the interesting thing that, for instance, when we talk about shipbuilding, right now the challenge of for a drone like ours to reach certain areas is because the ship was designed with the human in mind to perform certain kind of inspections. So certain areas are intrinsically difficult to access unless you're losing rope access or scaffolding. It's interesting to think that 10, 15, 20 years down the line, a ship or an offshore facility will be designed not with the human inspector in mind, but with the robot in mind.
Yeah, this is a very good point, because one of the program that we are launching as Accenture called Art of Reinvention starts from the assumption that might be the processes that we want to change has been developed some years ago for humans. Might be now it's time to revisit in a completely different way the process, because robots is different from human. Robots, software or hardware, whatever is different. I think that's fine. Okay. Any other question? Please, present yourself.
I got one. Yeah, I'm Andrea Manzoni from Jot Technologies. I'm an R&D engineer and data scientist. I have a quick question for all the speakers. And my question is, since we are talking about like robotics, and now robotics need autonomous robotics, and nowadays autonomous robotics require AI, and so training data set, and many of these training data sets are images, videos. So huge load of data set. And then someone of you also told us that nowadays that we can have continuous monitoring instead of spot monitoring. Both of these points drive towards a very energy consuming point. So since we're talking about robotics for energy transition, can robotics be considered a green technology or not at all? So yeah, sorry, he's a
That's nice.
provocative questions.
I think that I can speak about fusion technology. Okay, this is my role here.
So the question is if your robots will be, I would say, sourced by nuclear.
No. Of course, no. But in case we have energy from fusion systems, of course, there are no problems. I mean, robots takes a very small amount of energy produced by reactors. Apart from this, I can say that for the moment, the robotics for fusion probably is not a point, the autonomy. You speak about autonomy, you speak about energy. Okay, for the moment, remote handling is not focused on autonomy. It's focused on reliability, but also challenges on electromechanical design, challenges on radiation robustness against radiations. Okay, from my point of view here, autonomy is not the first point.
Yeah.
No, I can add something. Before I spoke about fixed sensors and the lander, our seafloor Bentic station. We spent a lot of time to design these systems to be very low power consuming. So this is a point. They are battery powered, but the point is to extend the operating life, reducing at the minimum the power consumption. So they are not so energetic demanding. Okay, for the other systems, so the drone and the clean sea, the subsea drone, the idea is to have in the future the docking stations which are powered by let's say, yes, green energy. Okay, so for the clean sea, we studied in the past the possibility to have power by tidal forces or wave forces and so on. So it's something we are thinking about. Okay, it's not ready yet, but we are thinking.
So they are not, robotics is not green today, but surely will be green in a way. When will be mature?
All the systems are electrical systems. So
yes.
In that case, you can have green energy. It depends on the source, of course.
Okay.
Question?
Please.
Hi to all. Emilio Alessandro, DG Impianti. I have just a question about the radiation robustness. You talked a bit just before. We heard some days ago about the A320 airplane of our Pope that was eaten by radiation from sunlight. So my question is, what is the way you protect the memories and computer CPUs inside the robot? Obviously, you cannot use a lid to envelop the robot.
It's very
maybe
difficult
you will
build with the lid. Okay.
Maybe I imagine there is a lot of work in the management of the software that must be self protecting in some way. Yes.
Yes.
I am very interested in this kind of little bit detailed information, if it's possible.
Yes, I'm not a an expert of this field, but I can.
Try also to answer after the wine.
If you want, just one point. My past experience, we worked also on space robotics.
Yeah.
And in space, there are some radiation, cosmic radiations. And there were an important activity based on make the software and the memories more robust to possible failure of some locations.
Error correction, something like this.
Yes, this is very, very similar to the robots to be used in fusion. In our case, we are developing a robot for DTT. And since the radiation level is not so high and is based on gamma rays in that environment, the philosophy that we want to use now is to adopt a predictive maintenance strategy. I mean, we use commercial electronics, but we take into account and integrate the time that the electronics is inside, and also the point in the tokamak where the electronics is. And we are able to compute the total dose absorbed by the system. After a given threshold, we decide to remove the electronics, replace with a new one, even if the electronics is still working well. Yeah. This is our strategy for the moment. But in our case, the system, our system that is the robotic remote handling for DTT is operating in an environment where radiations are not so high.
Thank you.
Okay, Arianna, I think that we don't have any more time. Right? Okay. One more time, I thank each of you, because I think that the discussion was quite fruitful from my point of view. As I said, I think that robotics is getting a lot of traction for several reasons. I think that's we discussed about demographic change, the people that are becoming older. I think that we discussed the technology, the role of NVIDIA maybe is something that's as having a role nowadays. I think that's there are three key messages that I collected from the discussion. One, and this is good, I think that's the SPE is a player from my perspective, and it is very important. There is across sector, across organization, collaboration for innovating. So now it's a moment where we can work together to improve the technology, whatever, more than competing each other. The second, I think that's we discuss about the workforce, the skill, the people. I think that's something that we need to design the robotics solution of the future. But at the same time, we need to work with our people to upskill them. Probably some of the work that they are doing today will be soon or is already doing by robotic solutions. Simply, they need to upgrade their skill and be comfortable to work with the robots. I think that this is another very important point. And finally, I think that's the university, research center, startups, the ecosystem is larger now. It's becoming larger every day. I think that this is a learning point for everyone, including Accenture, how to work with the ecosystem to improve the technology as the market is deserving for productivity. At the end, I think that is also, I'm used to say also to my clients sometimes that is an Italian play. I think that's also working together across the different company may be something that make Italy great again. Okay, thank you very much one more time. Oh,
bellissimo, cioè tantissime, quanto le hai incanto.
Grazie mille.
Grazie ancora.
Grazie.
Una bella